Bismillah ar-Rahman rahim. The CDF of a random variable y is given by fy of y is equal to 0 when y is less than 0, is equal to y cube when y is between 0 and 1, and this is when y is greater than 1. And the plot is given here, right? And find part A, the PDF of y, part B, the probability that y is between 1 over 4 and 3 over 4. So let's begin the solution. First, we need to find the PDF, the probability density function of y. So the PDF fy of y is given by the derivative of this uh, cumulative distribution function. So d by dy fy of y, right? So if we differentiate this interval, this is 0. If we differentiate this, this is 3y square. And if we differentiate this, this is 0, right? So it is 0 everywhere except for this interval where it is 3y square, the PDF, the probability density function. So we can just write it like this. Fy of y is equal to, so this is 0 when y is less than 0, and this is here 3y square when y is greater than or equal to 0 and less than or equal to 1, and this is 0 when y is greater than 1. So we can rewrite it in a more compact form. Fy of y is equal to 3y square when y is greater than or equal to 0, less than or equal to 1, and this is 0 otherwise. So this gives us the probability density function of this CDF, of this random variable y, for which the CDF is given here. So we can plot this function, the PDF. So for example, if this is y and this is fy of y, then you see it at 1 it becomes 3, right? And at 0 this is 0, and this is 0. For example, this is 1, 2 and 3, and at 1 this has a value of yes, let this be um, 1 over 3, 2 over 3, and 3 over 3, because the meaningful values are between this interval 0 and 1. Otherwise, beyond that, this is 0 otherwise. So, for example, at 1, this is if we put 1 here, this is 3. So, if this is 3 somewhere here, and at 1 over 3 it is this will be 3 into 1 over 3 square, so that will be 1 over 3, right? Again, so so the graph is something like for example, this at this value this becomes 1, and then for other values this is 0, right? So so the graph has the fy of y has higher value on the right side here. The density is higher for this value. So this means that there is a higher probability of finding y, random variable y, at the right side. So there is a higher probability of finding y at the right side of the graph, right? So furthermore, we can test whether this is a valid PDF or not. Probability density function is valid or not. So, for example, for a valid probability density function, the integral from minus infinity to plus infinity is equal to 1, right? The total area under this curve should be 1. So, for example, and we note that from minus infinity to 0, this is 0. For example, we can break this integral up for this particular PDF for example, uh, minus infinity to 0, uh, fy of y dy, then from 0 to 1, 0 to 1, fy of y dy, and then from 1 to further values to infinity, right? Fy of y dy. So this is 0. Fy of y is 0 for this interval from minus infinity to 0, right? So this is 0 for these values again, and for values greater than 1, this is 0. It's given here that it's 0 otherwise. So this part and this part is 0. The meaningful part is only this one. So we can say that and this should be equal to 1, right? So we can say that this integral should be equal to 1 because this is 0, this is 0. So this should be equal to 1. So otherwise the integral of fy of y with respect to y should be equal to 1. So the value of fy of y between 0 and 1 is 3y square. So let's substitute it here. So integral between 0 and 1, and this is 3y square dy. So this comes out to be 3 and y cube over 3. So over 3 I write it here, and this is y cube. So this is between 0 and 1. So this will be 1 minus 0, and this is 3 over 3 is 1. So this is 1. So the this shows that this PDF that we have found is a valid PDF because it satisfies this property. So now let's move to part B. Part B, we need to uh, find the probability that y is greater than 1 over 4 and less than 3 over 4. So we can find this probability using two methods. We can find the probability using the CDF given here, and we can also find the probability using the PDF. So let's find this probability using both ways. Let's find the probability first using the using the CDF. So for the CDF, we know that probability that random variable y is greater than y1 and less than a value y2 is given by the value of the CDF at y2 minus the value of the CDF at y1. So we need to just substitute the values of the CDF at 3 over 4 and then minus the value of this CDF at 1 over 4. So probability that y is greater than 1 over 4 less than 3 over 4 is equal to the probability, the value of the CDF at 3 over 4 minus the value of the CDF at 1 over 4. And from the given CDF, we see that at 3 over 4, this will be 3 over 4 cube. And at 1 over 4, it will be 1 over 4 cube. So this is 3 over 4 cube minus 1 over 4 cube. So this will be 3 into 3 into 3. So that is 9 into 3, 27. And that will be 4 into 4 into 4. So that is 16 into 4 is 64. And this will be 1 minus 64. So that is 26 over 64. And if you further simplify this, so 2 into 13 and 2 into 32, that is 13 over 32, right? So the probability that y is greater than 1 over 4 less than 3 over 4 is equal to 30 over 32, and we have found it using the CDF. So we can also find the same probability using the PDF. So when we find it using the PDF, then it means that the probability that y is greater than 1 over 4, less than 3 over 4 is the area when y is 1 over 4, right? And between 3 over 4 here, for example, so it is this area here which gives us this probability. And the total area under this curve is 1, as we have found here. The total area is 1. And if we want to find the probability that that y is greater than 1 over 4, less than 3 over 4, then this gives us the area between these two endpoints. So the area here will give us the probability. So using the probability density function. So probability that y is greater than 1 over 4 and less than 3 over 4 uh, is given by this integral, the area 1 over 4 to 3 over 4 fy of y and dy. So 1 over 4, 3 over 4, and we found out that fy of y is 3y square, right? So 3y square dy, right? So this is 3 and y cube over 3, right? So y cube over 3, so y cube, and the limits are 1 over 4 to 3 over 4. So this is 1. So this is y cube 3 over 4 cube minus 1 over 4 cube. So which is the same thing that we calculated here, and this will come out to be again to be 13 over 32. So that is 13 over 32. So the probability that y is greater than 1 over 4 and less than 3 over 4 is equal to 13 divided by 32. So this completes the solution to the given problem.